Yeah, because none of the other ones really make sense.
Dehydration.
Maisie, how did you understand that one but not the other one?
I don't know, I just know you become dehydrated.
Okay, here we go. Here we go. So close everything up. I want to go through a couple examples. There's
Oh, good at this game.
so
This is
I
gonna be
have
on
a
the
question.
Thursday.
yes, go ahead. Question.
Oh, no, like an actual question.
Like an actual
Like
question.
I need help.
Okay, so should we do that like on the previous assignment?
Yeah.
Let's do that first. Let's do that first.
It's on the last assignment, number 8.
Okay.
Oh, wait.
I got it right because
Okay. You guys, I got a little song for biology that'll really help you out. If you
I
just
wanna,
know
can you
this
sing
song.
it?
If you know this song, you know all biology. It starts out. Headphones connected.
Oh my God.
And then you just accept it. Just go.
Etc.
Alright. Okay, so let's take a look at this. We want to find the derivative, right? So first thing we got to do here. It's hard to see where the layers are if you're using the trig shortcut. So where does the 2 actually go?
outside.
Outside, and the 4 goes outside the inside, right?
Yeah.
So it'd look like this. So it's equal to the quantity cotangent of cosine t to the 4th squared, right? Okay, after a while you probably won't need to do that, but initially that really helps. I find that really helps students because it gets confusing to see which layer is which when you get lots of links in the chain, right? So then if we're doing a derivative, what's the first layer of the function is? Yeah, right? So what's the derivative of hand squared? 2 and to the first, right? Okay, and hand is just everything in the script brackets I'm about.
Yeah.
Okay, so then we peel away that layer and we're into the next layer. Well, the next layer is what? Cotangent. Okay, so, and let me just write this much in there. Inside, we've got a cotangent of something, right? So then the derivative of cotangent is negative cosecant squared of something, right? Okay, times next layer. If we look inside the cotangent, what's next? 4th, right? Inside there, I've got something to the 4th, so that's going to be a 4 times something cubed, and the something is just a cosine t. And then finally, the last layer would be inside the cosine. What's the derivative of cosine? Negative sine. Okay, and so how would we write this thing? So if we wanted to, with negative times negative is positive. I've got a 4 times a 2.
Wait, can you scroll for a half second? I'll
Sure.
make sure you can scroll back down.
Sure.
Thank you. Wait. Thank you. You look great in that.
Okay,
You go to the yearbook, Jill.
there you go.
Good for you, Mr. Williams.
Thank you. So 4 times 2 is 8. And then what do we got? Well, we got a cotangent of a bunch of stuff times a cosecant squared of a bunch of stuff times a cosine cubed of t times sine of t. And that's my answer. Right? Okay, does that help, Kate?
Yes.
All right, so for today, here's the topic of today. So if you wanted to kind of put a title on this in your notes or something, and I'll put these up there. All the notes are updated and the videos are updated, by the way.
Hey, wait, before you continue.
Okay.
You go back. Thank you. Oh, God.
So for today, what we're going to do is we're going to practice a very specific thing. So when we do products that involve the chain rule and the quotient rule or the product rule, it's not the calculus that's hard, it's the simplification part that gets a little more difficult. And so there's a really specific technique, and I want to teach this very carefully because this If you do this step by step and you really follow this process, you'll get it. But otherwise, this is something that I guarantee, this is something that tends to bother students, you know, is how do you get to the actual answer? So there's some ways we can do this that make a lot of sense, that relate to things you've done in the past. So let's just look at, before we jump into this, let's just practice factoring a couple things. And because if this, once this makes sense, simplifying the calculus will make sense. So how about something like, well, we'll start easy. So we're just gonna factor all this stuff. So 6x cubed minus 2x squared plus 10x is what? Thinking clear back to Algebra 2, what's the first thing we always want to do when we're factoring something? Factor out GCF, good, right? So what's the biggest thing I can undistribute from everything?
2x.
2x, which leaves me with
2x squared minus x plus 5.
and does that factor? I don't even care. I mean, maybe it does, maybe it doesn't. But this is what we're focusing on, is this, factoring out the GCF stuff, right? That doesn't factor anyway, does it? 15 multiplies 15 adds to -1, no dice. Okay. So how about this? 3x squared plus 6 minus 9x to the -2. So we can take a 3 out, right? What else? This is a little weird, right? And I'm not going to say that this is the only way to factor this, but you see a way that we could conveniently factor this? You could, but I'm going to actually not. I'm going to leave it this way for a reason. If I think of that as something over x squared, that's a little bit inconvenient, right? To have a trinomial here. It's not even really a trinomial because that's a negative power of x, right? But to have this function where I've got these 3 terms and one of them is an x to the -2. I'd rather have the 3 term, I could factor out an x to the -2. And think what my reasoning is then. What I'm left with if I do that is a legitimate polynomial, right? I end up with all the powers being whole numbers, 0 or positive integers, right? Okay, so if I factor out an x to the -2, what am I left with? Now, when I factor something out, remember, that's just a process of division. If I want to find out what's left behind, all I have to do is divide each term by the GCF, right? So what is 3x squared divided by 3x to the -2?
X to the 4th.
X to the 4th, right? If I divide like bases, I just subtract exponents, okay? What is 6 divided by 3x to the -2? 2x squared, right? And then finally, what is -9x squared divided by 3x squared, or 3x to the -2, sorry, -9x to the -2 divided by 3x to the -2? -3. Okay? Make sense? And so then, this doesn't factor. Actually, it does factor. We could go a little further. Are there magic numbers that multiply to -3 and add to 2? Okay, so I could write this as 3 over x squared if I want to. I could leave it as 3x to the -2. And then x squared, not that I'm even really focusing on this part. This is just kind of a little extra bonus practice you get here. So x cubed plus, or x squared plus 3, x squared minus 1. And then while we're at it, what is that?
X plus 1 times x minus 1.
Good, difference of squares. And like I say, I'm not even that concerned about all this other stuff. This is, the main focus is that part right there, right? That's the part I want you to see. Turns out we can actually go a little further. Okay, everybody with me? So if I wanted to write this then as a rational function, which is probably the best way to do this, I would just write this as 3 times x squared plus 3 times x plus 1 times x minus 1 over x squared, right? Think why that would be. What's our motivation? We're not doing this yet. This is next unit, but what's our motivation for writing it this way? You can tell me a lot about this function by having it factored that way, right? You could tell me where are the x-intercepts?
Square root of 3?
No. The x-intercepts are the zeros of the numerator, right? Exclusive zeros of the numerator. So that's going to be
1, negative 1.
1, negative 1. Everybody see that? Those are the values that make the top 0 but not the bottom, right? So those are, I could ask you, where are their holes? Well, there aren't any, because there are no shared zeros of the top and bottom. Where are the asymptotes? 0, right? Because x equals 0 is a 0 of the bottom but not the top. Everybody see that? I mean, I'm not going to focus on that today, but you see the utility in doing something that way, right? In writing it top factored, bottom factored. Okay? Question? Oh, okay. Okay, another one. So what about, I'm going to skip ahead a little bit. What about, well, now this. Okay, nobody say it out loud. Everybody just look at that for a second. Raise your hand if you want to take a stab at this. GCF? X minus 2. Yeah, good. No, it's not. It's not that hard, but I just want you to see. I mean, sometimes people have a hard time seeing that if you have a quantity like that, you know, that is a factor, right? So then what am I left with if I do that? 7 times
Quantity x minus 2 minus 3.
minus 3. Good. Okay, and then all we have to do now, if we want to write this in factored form, there's a factor, and then this is going to be a factor once I simplify it, right? If I just distribute the 7 and add like terms, I get x minus 2 times what? 7x minus 14 minus 3, so 7x minus 17. Okay, it's factored. Now we can see where the zeros are easily, right? Okay? Questions? Okay. How about this guy? Okay, think about that for a second. So yeah, what's going to be the GCF here? Okay, good. So what'd you see, Katie? How'd you get that? So the 2 and 4, the greatest common factor is 2.
Yeah, x.
And then, now notice, we've got like bases here, right? We look for factors of like bases. So factors built from like bases. I've got x's and x's that are factors, right? So if I'm going to factor out the greatest common factor, that's going to be the least power of the common base, right? In other words, this one's only got x squared to give, but this one's got x cubed, right? Okay, so we're going to take out a 2x squared. And then my other base, I've got the quantity x cubed minus 1 to various powers, right? The least power of my common base is cubed, right? So then we get x cubed minus 1 cubed and then I got a bunch of leftover stuff, right? So if I divide all this away, what am I left with from term number 1? And how many terms are there in my original expression? 2, right? Here's the plus sign that separates the 2 terms, right? So from the first term, what's left over if I divide this stuff away?
2x.
4 divided by 2 is 2, right? X cubed divided by x squared, x. X cubed minus 1 quantity cubed divided by itself is 1. So that's all that's left from the first term, okay? What about second term? So there's my plus sign. Okay. So I'm dividing 2 and x squared by 2 and x squared. So those go away. The hand to the 5th divided by hand cubed is just hand squared. Right? So I end up with okay, makes sense? So if I wanted to write this in factored form, I've got a constant factor, which I don't care about. I've got 2 variable factors. And then I've got this other thing that's trying to be a factor. What would I have to do to write that as a factor? Yeah, just simplify, right? So expand this out and add like terms. That makes sense? Okay, no big deal, right? We could do that. We don't have to do that right now. Okay, how about this? So far, so good, right? Are we good so far?
Yeah.
Okay, here's the next step. Now think what you want your answer to look like. Or we want our answers always to look like, and we haven't had very many of them that have been this way, but we had one where we got a bunch of stuff on the top, factors on the top, and factors on the bottom. So if we're going to have denominators, we want to be able to write it as a rational function, like it's a factored rational function, okay? Meaning polynomial over polynomial, right? So what about this case then? What kind of throws a wrench in the whole process here that makes it look harder? The denominator, right? The denominator. So there's a couple ways. I mean, we have different approaches to this, but this is the easiest way. We could just try to add up all these fractions, but we'd rather not have to battle the fractions the whole time. Instead, let's just factor out the least common denominator, the least common multiple of all the denominators. What's that going to be? 1 over 6. Everybody see that? 1 over 6. So if I factor out, let's just deal with the number part first. Right? So if we factor out a 1 over 6, what's left over?
18x squared.
Okay, well, factoring out, remember that what I factor out is what I'm dividing each term by, right? Like if I factored out a 2, I'm going to divide each term by 2 to see what remains, correct? So if I'm factoring out a 1/6, I'm dividing everything by 1/6. Well, that's multiplying by 6, right? So I'm just going to distribute a 6 through all these terms and get 18x squared minus 3x plus,
2x.
and then what would I combine if I factor out my least power of x? Because look, I have x's in each term, so that's my common base, right? What's the smallest power of x? -1, right? So we're going to get an x to the -1 over 6 times what? What's it going to be? Gilsdorf, what are we going to get here? If I factor out an x to the -1, what am I left with there? Cubed, good. Minus
3x squared
good. Good. Okay, and then that x to the -1, where would that go? On the bottom. So if we write this as one big rational function, then I've got on the top 18x cubed minus 3x squared plus 2 divided by 6x. Okay? That's better. Can we factor the top? No. But we can at least, it's easier for us to find the zeros of the top if it's written as a polynomial. Okay? Zeros are the bottom. 0. 0 is clearly not a 0 at the top, so that tells us something important. We have an asymptote at 0, right? Okay? All right, last one. Here's a granddaddy of all. You can do this one. You're in great shape. Even if you can't, you're probably in great shape. But this is a harder one.
So this is just like a help us do it?
What's that?
This is kind of help us.
Yeah, right. This is just to help you. Well, once we get to the calculus, it'll be easy now because we've already thought about the factoring part. I just don't like to, if you get too many thoughts strung together, it's hard to keep track. You know, like if we're doing a calculus problem, then we got to stop and think all about the factoring part, then you kind of lose track of the calculus part, right? So we're just going to practice our factoring and then we'll put it all together. So what about this? Okay, first step is don't panic. Right? This is all stuff that we've dealt with already. We can think about how to, we got fractional exponents, but that's all right. They're just numbers, right? So first things first, what do you think? What could we take the numbers? What numbers could we factor out?
Let's take out a 1/2.
We could take out a 1/2, that's fine. We could undistribute a 1/2. While we're at it though,
And
20 and 5, there's a common, in the numerator, what number could I take out? What's the GCF of 20 and 5? Right, so what if we factored out a 5/2? Let's do it in one step, right? So if we take out a 5/2, and while we're at it, it's easy for us to get maybe a power of x. What power of just the base x could I undistribute? X cubed, okay. Let's just stop there for a second. I mean, and eventually you could do this all at once, but let's just pause there. So what are we left with? If I factor out a 5/2, that's equivalent to distributing a what? Right, because whatever number I factor out, if I want to know what's left over, I'm just going to say each term divided by that number. No? No, think back here. Think back, let's go back a couple steps. When we took out like right here, I mean, this is a real simple one, but if I take out a 3x to the minus 2 from this thing, right? There's our first step. What did I do? Well, whatever I factored out, I just divided each term by that to see what's left over, right? So 3x squared divided by my GCF, you told me was x to the 4th, right? 6 divided by my GCF, you told me was 2x squared, and negative 9x to the minus 2 divided by my GCF was negative 3. So I just divide by the GCF to find out what's left behind, right? So now if I'm dividing by 5/2 x cubed, well, that's dividing by 5/2 is the same as what? Multiplying by 2/5. Yeah, right? So all I'd have to do then is distribute that through. So what's going to be left here then? 20 divided by 5/2 is just, oh, you guys told me 8, didn't you?
Yeah.
I get it. I get where that came from. Yeah. I got you. My mistake. Okay. So from the first term, we're going to get an 8, and then the x cubes cancel. So just x squared minus 1 to the 1/4. Here's my plus sign, my plus sign that connects the two terms. Right, and then over here, 5/2 divided by 5/2 is 1. X to the 5th divided by x cubed is x squared. Okay, so far so good. Now what? What other common bases do we have there? X squared minus 1. So now this is going to be a little strange, but if we've got x squared minus 1, right? What's the least common power, the smallest power of the base? Negative 3/4. Right. So then we could couple out in the front. We could, with our GCF, we could add to that, not add to that, we could contribute the additional factor of x squared minus 1 to the negative 3/4. So we got times now what's left behind if we do that?
X squared minus 1
Okay, so there I've got an 8.
plus 1.
No, hang on. What's x squared? So, and the x squared minus 1 looks complicated, but I've got hand to the 1/4 divided by hand to the negative 3/4.
You add 3/4 to the top and you get 4.
Does that make sense? So if I've got hand to the 1/4 divided by hand to the negative 3/4, remember what our rule is. If we have divide like bases, we subtract exponents. So don't I get hand to the 1/4 minus negative 3/4? That's 1, isn't it? Right? So I'm left with, yeah, go ahead. So here I'm left with a hand to the 1, which we wouldn't write, but there it is, right? Plus, what about over here? Well, I'm just dividing this factor by itself, so that's going to cancel. So I just end up with x squared, and that doesn't look too bad now, right? The negative exponent just means it goes where?
On the bottom.
To the bottom, right? Wow. So now we just draw one big bar that separates the numerator from the denominator. On the top, what do we get? A 5x cubed. And then this stuff, right? On the bottom, we sent the 2 to the bottom. We sent the negative exponent to the bottom. And then all this stuff just combines into one factor. So what am I going to get? 8x squared minus 8 plus x squared. So 7x squared minus 8. Right?
9x squared.
Oh, 9x squared. You're right. There you go. 9x squared, that's what I meant, see? 9x squared minus 8, okay? And we're good. We've got it written as a rational function that's factored. So you tell me, where are the horizontal asymptotes of this thing? At 1, yeah. Right, everybody see that? Oh, actually, and negative 1, right? Negative, plus and minus 1. Okay, where, give me an x-intercept, give me a 0 of the function.
0.
0, right? And I get 2 more coming from this, so I'm going to get, what, plus or minus the square root of 8 ninths. Would be my other 2, right? That's useful, we got this thing in a useful form, okay? All right, so now let's actually do a couple calculus problems where we use this. So,
So are we in calculus now? Are we doing full calculus?
oh, we're full on calculus, yeah, this is.
I like calculus.
Dude.
Good at this stuff. Not
Oh, let's do,
Can I add it to you?
no. My apologies.
okay, there's the function. Let's find the derivative. Okay, so the first thing you got to do when you look at this is you got to kind of just blur your calculus vision and say, what is that? Is it a power? Is it a product? Is it a quotient? What is it? It's a product, right? I've got a factor times a factor, right? So it's a product. I could put, there's a times sign between those two factors, right? So I got to use the product rule, just u times v. So when I do the derivative then, what's my derivative going to be? So uv prime, what's that going to look like?
X cubed.
X cubed is my u. V prime is going to be, that's v. I got to take the derivative of all that. Right, so let's, hold on. Right, so let's just kind of digest this. If that's v prime, that's a chain rule issue, right? You got 2 layers. Yes, sir. You could, but some of them, I'm just practicing on an easy one. Some of them you can't. So the derivative of v, what's that going to be? Hand squared is?
2 times hand, which will give us 6x minus 2.
Okay. But we're not done.
Times.
Because I got to go derivative of hand, which is 3. Okay. Plus v du, right? So I've got v times derivative of u. Okay, do you see why we were doing all this stuff? Right, look, what we got a bunch of just stuff to factor out and have to clean up. What can we factor out? Well, what's the biggest number I can take out? 3, it looks like, right? Take a 3, I've got powers of x, that's one base. What can I factor out? X squared. I've got powers of 3x minus 1. Okay, what's left behind? So if I'm dividing this term by all this stuff, I could cancel 3's. I'm left with what? 2x, everybody agree?
2x plus 1.
No.
Times 3x minus 1.
Plus, here's my plus sign.
Oh, plus 3x minus 1.
So then over here I can take out the 3, I can take out the x squared. I'm left with 1, with a 3x minus 1 to the 1. Right? Everybody see that?
That is so much more satisfying.
Okay, and why do we get that? I mean, because really all we're doing is each term, we're just dividing by that stuff, right? To see what we get left over. Okay. And then I won't even finish this. Then all we have to do is just combine that into one factor. Okay? How much time we got?
6 minutes.
Okay, that's good. We're going to finish this. We're going to do one more, and then we're done. And that, all right, so Monday's clear. Okay, here's another one. Okay.
That assignment we got today?
We got it right after each other.
Which
First
one were you
one?
working on? No, it's like number 4. Number 2 through 4 are easy
I'm
though.
so confused.
Well, we just didn't write it, we got the exact number.
All right, here we go.
They are, I think.
The correct answer is you love physics, by the way. That's the correct answer to all physics questions. That's really a question. Okay, so what product, quotient, what do we got here? Product. Okay. So let's go ahead we could pull the 3 out in front of the whole thing. Sometimes I just do that rather than have to mess with that. I just put the 3 with the x cubed, right? We'll factor everything out later anyway, okay? So there's u and v. Now on these, you'll see this, but we don't have much time. I would always start with the radical being the one that you don't differentiate first. Okay, and just trust me on that. That's a little easier to do. It doesn't make that much difference, but it's a little bit easier. So let's keep this one the same, keep this by itself, and differentiate that one first, right? So call that u and call that v. And what power is that, by the way?
1/3.
Okay, let's write it as a power. Times the derivative of that. What's that? What's the derivative of that factor? Okay, plus 3x cubed times the derivative of that, right? X squared plus 4 to the 1/3. What's that?
Negative 2/3.
No,
And negative.
no. 1/3, right? I got to take the power down front, so I'm getting 1/3 times hand to the negative 2/3. Third. And then I got one more layer. The derivative of hand is,
2x.
okay, so some good stuff happens. The 3's cancel. That's good, right? And now, I mean, I could clean this up a little bit, but don't bother. Just factor out the greatest common factor. What's going to be, are there any numbers you can take out? All I've got is a 2 and a 9, so I'm stuck, right? No, there's no GCF number. What about the powers of the base x? Here I've got an x squared. What do I have here on this side? I got an x cubed times an x. X to the 4th. Okay, so we'll factor out an x squared. What about the other base? Okay, does everybody see that? The lesser of the two powers of the other base, the x squared plus 4, is the negative 2/3, right? So we'll undistribute x squared plus 4 to the negative 2/3. Now, what's left behind if we do that? So here I've got a 9, right? X squared divided by x squared, that one's gonna cancel, right? I've got a hand to the 1/3 divided by a hand to the negative 2/3. Hand to the 1. And is that an accident that it worked out so nicely? No. I think it's always going to be different by 1, isn't it, when you differentiate? Because by the power rule, we subtracted 1 from the exponent to get that, right? So it always works that way. So we're left with 9 times hand. Whoops. Right, to the 1, 2 and right. Plus, what about this side? We factored out an x squared, so we could cancel an x and an x, leave me with an x squared, and I've got a 2, I guess, right? And then I'm dividing hand to the negative 2/3 by itself, so that goes away, right? That cancels. Everybody see? And so I'm left with that. Now that looks messy, but what do? Well, where's the negative exponent? Put that factor on the bottom. This is just going to build one factor when I clean it up. And so when I write this as a rational function, I mean, it's not truly a rational function, but I write it as a ratio of functions. I end up getting x squared times what? 9 plus 2 is 11 plus 36. Did I do that right? I think so. And on the bottom I get x squared plus 4 to the 2/3. And we're done. How about that? Okay. Wow, that was a lot of math in 45 minutes.
Oh, no.